Hello dear friends, welcome to the lecture of solid geometry. We are studying the right line, that means the straight line in three-dimensional geometry. And last time or in the last lecture we have seen the equations of line. We also solved the problems on equations of line, and there are two important forms of equations of line. So I have written these forms again, and in this lecture we will see how to transform one form which is unsymmetrical form of equation of line to symmetrical form of equation of line, and then we will solve some problems. So first we will see what is the unsymmetrical form. We know that two planes together represent a line, or because their intersection is a line, and therefore equations of a line is equations of a line are given by two planes together, that is ax plus by plus cz plus d is equal to 0. This is first degree equation, represents a plane, and this is second plane. So these two together represents a line, and this form is known as unsymmetrical form of equation of line. And another form we have studied is line passing through the point x1 y1 z1 and having the direction ratios ABC or direction cosines, but in general the direction ratios will be there, and thus the direction ratios are ABC, and that equation we have seen is x minus x1 divided by a is equal to y minus y1 divided by b, etc., and this form is known as symmetrical form. So these are the two forms, two planes together, and this form. So this form, symmetrical form, is important because it gives the equation of line passing through a point and having the DRS ABC. So if the unsymmetrical form is given, and if you want to transform the form to symmetrical form, so that is transformation from the unsymmetrical form to symmetrical form. So we shall first obtain this transformation, that is to transform the equations, these equations of a line to symmetrical form. So this part we will first do. We will obtain the transformation, how to do the transformation, and then we will solve the problems on it. I have written the problems also here. So first we have to do this, and thus we shall start with the transformation of equation of line from unsymmetrical form to symmetrical form. Now we know to write the symmetrical form, what are the requirements? Two things are required, and that is a point and the DRS ABC. Then we can write this symmetrical form. So therefore, we require two things. We require first thing is, we will consider first the DRS ABC, and instead of ABC, because ABC are used as here in the equation of plane, we will denote the DRS by LMN. We require the DRS, the direction ratios, LMN of the line. This is first thing. And second thing, we require a point, any one point, any point. So this line, and the second thing, a point, that is x1 y1 z1, and any point on the line. So these two things are required. And first we will see how to obtain the LMN, the direction ratios of the line. Now see, because the line is the intersection of these two planes, the line lies in both the planes. The line lie on both the planes, or the line lies on both the planes. The planes are these: ax plus by plus cz plus d is equal to 0, and And because the line lies in the plane, that means the normal to this plane is perpendicular to the line. See, if the line lies in this plane, this is the line, then the normal to the plane is perpendicular to the plane as well as the line. So this happens for both the planes, and therefore the line is perpendicular to both the planes, perpendicular to the normal of both the planes. Perpendicular to the normals of both the planes, and whose DRS are, or direction ratios are. Normals, and we know what are the DRS of normal to the first plane, direction ratios of the normal to the first plane. The coefficients of x, y, z represent the direction ratios of the normal. So, and thus the direction ratios, whose direction ratios are ABC, and second A1, B1, C1. These are the direction ratios of the normal to both the planes, and the line is perpendicular to these normals. So now we use the condition of perpendicularity. By the condition of perpendicularity, so what we will have? See, the line has DRS, direction ratios of the line, we have assumed as LMN, and the normal, first normal has direction ratios ABC. So these two are perpendicular lines. That means their sum of product is equal to 0. That gives A into L plus B into M plus C into N is equal to 0. And now the same line is perpendicular to the normal of the second plane, whose DRS are A1, B1, C1. So second condition will be A1L plus B1M plus C1N is equal to 0. So we have this, and the line is perpendicular not only to first normal but to the both the normals of the planes, and therefore we have this two relations. From this we shall have to find out the proportional values of LMN, and so this implies, so we will solve the two equations to get the LMN, proportional values of LMN, and that by Cramer's rule this gives L divided by, we hide this first terms and then write the coefficients of Mn column wise. B, B1, C, C1 is equal to M, and we hide this, but we write this column first, C, C1, or we have to write negative sign and then the column A1, C, C1. So, and is equal to N, hide this, and A1, B, B1. And this gives L divided by BC1 minus B1C, and this is equal to M CA1 minus C1A, and N AB1 minus A1B. So these are the DRS of the line. So therefore the DRS of the line are, we have obtained the DRS of the line are BC1 minus B1C, next CA1 minus C1A, and AB1 minus a1b. So thus we have done the first part to obtain the DRS of the line, and now we shall we have to find what the next require is we have to find a point on the line, and that we will obtain as the intersection of the planes with z plane. Z is equal to 0 plane, or which is actually xy plane, to find any point on the line. Next we shall find the point, or we have to find any point, and that point may be obtained with the plane either z is equal to 0 or x is equal to 0 or y is equal to 0. These are planes, and the given planes are, we have ax plus by plus cz plus d, etc. So we have to find the intersection of these two planes with either of these planes, and for simplicity or for example, we can consider z is equal to 0. Any one plane can be considered and get the intersection of that plane with the given planes. So what are the given planes? The given planes are ax plus by plus cz plus d is equal to 0, and this one. So these together represents the line, and we want a point on the line, so therefore we shall take the intersection of these two planes with either of these plane. And why these planes are considered? Because these expressions are simple. So this is actually xy plane. So we have to consider the intersection of the line with xy plane, or with this is the plane yoz plane, and this is the plane xoz plane. Any one plane. So we consider this plane. So we shall find intersection of the line, a point on the line by taking its intersection. Intersection with the plane z is equal to 0. This is the plane we have selected, and therefore this point is given by, and that is, if the line cuts the plane, let the line cuts the plane whose z coordinate is 0, and x coordinate may be considered as x and y. So this gives, this point is given by. Now how to obtain this point? We have to take the intersection of these two planes with this plane, and see the intersection of these two planes gives z is equal to 0 here in both the equations. So therefore this point is given by ax plus by plus z is 0 and plus d is equal to 0, and second a1x plus b1y plus z is 0, so this term is 0, plus d1 is equal to 0. Now you should note this again. So how to obtain a point on the line? So DRS we have obtained, and we have to find a point on the line. We will take the intersection of the line with any of the coordinate plane. That plane we have considered z is equal to 0. We may consider that as y is equal to 0 or x is equal to 0. Why? Because it gives us simplified equations. If one coordinate is 0, then the equations we will get in terms of only 2 x, y. And now we can find out the value of x and y from this equation as in earlier. So this implies, or solve these simultaneous equation in x and y. And if you use again the Cramer's rule, then this will imply x divided by b1 dd1 is equal to y divided by, and this will be d1 first column a1, and this is 1, the coefficient here is 1, and that gives the determinant aa1 bb1. So therefore x is equal to, x is, now we shift this denominator on that side, and the value of this is bd1 minus b1d divided by, and the value of this determinant is ab1 minus a1b. Y is equal to, again shift this denominator here, and its value is dA1 minus D1A divided by the same AB1, denominator is the same, AB1 minus A1B. So thus we obtain the x coordinate and y coordinate, and z coordinate is 0 because the intersection is taken with the plane z is equal to 0. So therefore a point on the line is, a point on the line is this one, x y 0, or that is bd1 minus b1d divided by and z is 0. So this is the point, and thus we have obtained the DRS of the line. So these are the DRS of the line and a point on the line, and now we can write the equation of the line. So using the point, passing through this point and having the DRS. So therefore the equations of the line are, equations of the line are x minus x1. This is, now we have to consider the coordinates of the point as x1. This is bd1 minus b1d. This is a point on the line, divided by ab1 minus a1b divided by the DRS first, bc1 minus b1c is equal to, now y minus y1. y1 means the coordinate of a point on the line. So the point on the line is this one, and that is dA1 minus D1A divided by and the direction ratio is CA1, second ratio CA1 minus C1A, and this is equal to again Z minus 0 divided by the point Z coordinate is 0 divided by the DRS third is AB1 minus A1B. So these are the equations. This is the symmetrical form of. So thus we have transformed unsymmetrical form to symmetrical form, and for that purpose, so we have obtained two things. First we have obtained the DRS of the line, because the line is perpendicular to the normals. We have obtained the values of DRS, and then to obtain a point we have considered the intersection of the line with the plane Z is equal to 0, and the Z coordinate becomes 0. We have obtained x and y values by solving the equations, and then using the earlier form of equation of line, that is passing through this point and having this DRS, the equation is given by x minus x coordinate of the point divided by the first DRS, etc. So this is the symmetrical form of equation of line, and this completes the derivation. Now we will solve problems depending on this. So I have written the problems on this side, we will consider or we will solve these one by one. Now what is the first problem? See, put the symmetrical form the equations of the line. Now the procedure that in the derivation will be more clear in solving these problems. What we have done in the derivation, that can be more clear from these problems. Now first solution for the first problem. The given line is in unsymmetrical form. We have to put the line in symmetrical form. So given line is it is two planes together, unsymmetrical form, ax plus by plus cz etc. And second is 4x plus y minus 2z plus 2 is equal to 0. Now we start with, let LMN be the direction ratios of the line. Then we have, now we know that if the direction ratios of the line are LMN, then this line is perpendicular to the normals. So therefore we use the direction ratios of the normal will be 1, 1, 1, and here the direction ratios of the normal to the second plane is 4, 1, minus 2, and use the perpendicularity condition between these two. So then we have 1 into L. So we will write directly 1 into L, 1 into M plus 1 into N is equal to 0. Condition of perpendicularity, that is AL plus BM plus CN is 0. Here A, B, C are 1. And second is, what are the values of A1, B1, C1? That is 4. 4L plus 1 into M minus 2 into N is equal to 0. So this implies the same procedure we are using as we have done in the earlier theory result. So this gives the value of L divided by the determinant. Say hide this first part, and then we will get 1, 1, 1 minus 2. And this is M divided by, hide this one, write this column first, 1 minus 2, and then 1, 4. And this is equal to N divided by, hide this, 1, 4, 1, 1. So thus this after simplification gives L divided by minus 2 minus 1, that is minus 3, and this is M divided by, it is 4 plus 2, that is 6, and N divided by, it is 1 minus 4, that is 1 minus 4 minus 3. Check it. Or this can be simplified. See, these numbers are divisible by minus 3, or that is, we can write L divided by 1. So divide or multiply this ratio by minus 3. If you multiply each by minus 3, then it is L divided by 1, M divided by, this will be minus 2, and this is equal to N divided by 1. So the DRS of the line are 1 minus 2, 1. So therefore the DRS of the line are, these are 1 minus 2, 1. Thus we have obtained the DRS of the line. Now the next part is to obtain a point on the line, and that we will do now. To find point of on the line, we will consider the intersection of this line with the plane Z is equal to 0. Let the line intersect. Further, let the line intersect the plane Z is equal to 0 in point. So the point may be considered as x1, y1 and 0. So Z is equal to 0 means Z coordinate is fixed to be 0. So we will suppose the coordinates of in point x1, y1, 0. So then this gives, or this gives. So what is the intersection of the line? See the equations of the plane. Equations of the plane are these. These equations we have written at start, and these planes intersect with the plane z is equal to 0 in point. So therefore we can write the equations in terms of x1, y1. So this gives x1 plus y1, z is 0 plus 1 is equal to 0. We have to write from these equations. Only put z is 0, and because the coordinates we are assumed as x1, y1, in place of xy we write x1, y1, or you may write directly as xy also. So and second will be 4x1 plus y1 and z is 0 plus 2 is equal to 0. Now these are two simultaneous equations. We may use Cramer's rule or we may solve this. So solving these, what we shall get is, see, it is simple to solve simultaneous equations by elimination procedure. Subtract second from 1. So 1 minus 2 gives, see, x1 minus 4x1, that is minus 3x1, this is 0, and 1 minus 2 is minus 1 is equal to 0. And therefore what is x1 will be negative 1 by 3. And thus what is y1, and therefore from first, x1 is minus 1/3 plus y1 plus 1 is equal to 0, and therefore y1 will be minus 1 plus 1 by 3, or that is minus 3 plus 1 minus 2 by 3. And thus a point on the line is, therefore a point on the line is x1, y1, 0. Only the change we have done is in the theory we have denoted the point as xy 0. Here we are considering it is a particular point because x1, y1 and 0. That you should note. And therefore what is the point? x1 is minus 1/3, y1 is minus 2/3, and z is 0. And thus we have obtained this point. And now we can write the equations of the line using the DRS. Therefore the equations of line are, thus the equations of line are passing through this point. So x minus 1/3, that is x plus 1/3, divided by the first direction ratio, and y plus 2/3 divided by the second direction ratio, and is z minus 0 divided by the third direction ratio. Now I have removed the part that we have obtained DRS. So you please write these values here. ABC LMN values we have obtained, and that gives the equation of the line. So this is the required equation. So put the values of L, M, N here. That was we have done in earlier. So what we have obtained is L plus M plus N is equal to 0, and 4L plus M minus 2N is equal to 0. From this we have obtained the values of LMN. Put these values here. So this is the required equation. These are the required equations of line. Of the line in symmetrical form, and thus this gives this completes the solution of the first problem. Now we will consider the second one. The second problem is find the equations of the line. Solution for second. Find the equations of the line through the point 1, 2, 4 and parallel to the line. we have to find equation of the line passing through this point. That means so one part is already done. The point is given. Only we need the DRS of the line, and then that gives the solution for the second. The line given, the line is parallel to this line, means the line is parallel to the planes. Given, let first we will consider let LMN be the DRS or be the direction ratios of the line. Given the line is parallel, to the planes. The line is parallel to the intersection of these two planes, means the line is parallel to each of the planes. Line is parallel to the planes, that is 3x plus 2y minus z is equal to 4, and the second is x minus 2y minus 2z is equal to 5. And therefore the line is parallel to the plane, means the line is perpendicular to the normals of these planes. Therefore the line is perpendicular to the normals of these planes, and this gives, so then we use the perpendicularity condition. The ratios are direction ratios of the line are LMN. The direction ratios of the normal are 3, 2, minus 1. So that gives 3L plus 2M minus N is equal to 0. And the second gives, this is 1 into L, and next is minus 2 into M, and minus 2 into N is equal to 0. So again this implies we will obtain the values of LMN from this, that is L divided by, and this is 2 minus 2 minus 1 minus 2, M divided by, take this column first, minus 1 minus 2 and then 3 1, and N divided by 3 1 first column, second column 2 minus 2, or that is L divided by, so this is minus 4 minus 2, yes, minus 4 minus 2, that gives minus 6. M divided by, this is minus 1, you should check these calculations, minus 1, and this becomes plus 6. So minus 1 plus 6, and that is 5. And N divided by, this is minus 6 minus 2, and that is minus 8. So these are the DRS of the line. So that in earlier problem we have obtained the values, and I have removed the values, so we have to remember these values. These are the DRS of the line. So therefore minus 6, 5 and minus 8 are the direction ratios of the line. Now the point is given. So here in this problem it is easier. The second part is already given. Given that the line passes through this point. Through the point 1, 2, 4. Therefore, the equations of line are, now you see, x minus x1, x1 means 1, divided by first ratio minus 6 is equal to y minus second point is 2, and second ratio is 5, z minus 4 divided by minus 8. So these are the equations of the line, and this completes the solution for the second problem. So you should see the procedure that we have used. What is the main thing is to find the DRS of the line, and then we require point on the line. So here we obtain the DRS of the line by using the line is parallel to these planes, and then the point is already given. In earlier problem we have obtained the point also by taking the intersection of the line with the plane z is equal to 0. So this is the difference in the first problem and the second problem, because the conditions are given differently. Now I have written here third and fourth problem, so you should solve these problems yourself. So please try to solve third and fourth problem. Find the equations of the plane. What is the third problem? Find the equations of the plane through the point. Here the equation of plane is asked, not the line. Equation of the plane is asked, and through this point, and we know how to write equation of plane. So I shall only write the hint for the third problem. Equation of plane passing through this point. Equation of plane through 1 1 1, that we can write as is a into x minus 1 plus b into ABC are the DRS of the normal that we have to consider, and further b into c 1, again the point y coordinate is 1, so therefore it is b y minus 1 plus c into z minus 1 is equal to 0. The equation of the plane is, and we refer this as 1. Now what we require is ABC. ABC are the DRS of the normal, and it is given that the plane is perpendicular to this line. So further, given the plane is perpendicular to the plane, say yes, perpendicular to the planes. Perpendicular to this line means it is perpendicular to both the planes, represented in the equation of line. Perpendicular to the planes, say x minus 2y plus z is equal to 2, and second is 4x plus 3y minus z plus 1 is equal to 0. And here let ABC be the DRS of the normal to the plane. Use the condition of perpendicularity for this. That is, we will have 1 into a plus minus 2 into b plus 1 into c is equal to 0, and then 4 into a plus 3 into b etc. minus 1 into c is equal to 0. In place of LMN, here we have denoted ABC be the direction ratios. Let ABC be the DRS of the normal. Be the DRS, direction ratios of the normal to the plane, of normal to the plane. Or that is assumed that if the equation of the plane is written in this form, then ABC are always DRS of the normal. Use perpendicularity condition, find ABC. Find ABC and put the values in 1, that gives the solution. For the second problem, fourth one. Find the point of intersection of this line, that unsymmetrical form, with xy and yz plane, and then write the equation in symmetrical form. Now here we will obtain the intersection of this line with xy plane. And what is the equation of xy plane? Xy plane is z is equal to 0. And we have done this in the theory also in problem. So how to find the point of intersection of these two planes with z is equal to 0? Put z is equal to 0, we will get two equations in xy, and find the point, we will get 1 point. And further, equation of which plane is there? YZ plane is x is equal to 0. So put x is equal to 0 next, that this gives 1 point and this gives another point. Then obtain points of intersection. And then use 2-point form of equation of line. of equations of line. We know how to write equations of a line passing through 2 points. So for this gives 1 point, this gives another point. Here z is 0, z coordinate is 0, here x coordinate will be 0. That means in this case we have to put z is equal to 0 in this, find the values of x, y and z is 0. Here put x is equal to 0 in these two, find the value of y and z. The point will be 0, y and z, and then use 2-point form of equations of line to write the equation in this form. So please try these two problems yourself, and the remaining part we will continue in our next lecture. Thank you.